All right, now we have this new thing called a segment of a circle. A part of a circle bounded by an arc and the segment joining its endpoints is the segment of a circle. It looks like this. This whole shaded piece here is called a segment of a circle. Yep, the white part's also a segment. You're right. By definition. I'm trying to think of anything circular that we would cut that way. We don't normally cut food that way. But isn't that square pizza or rectangular pizza? Cheese bread gets cut that way. You're right. Okay. So how would we find the area of one of these things? We know how to find the area of one of these things, right? So how would we find the area of this segment? Well, let me give you another hint. We can find the area of a sector. We can find the area of a triangle. How would we get the area of a segment that's out here? The piece on the other side there.
Find the area of the whole thing and then just take away whatever that little bit is?
Yeah, if we take the area of the sector, and maybe you said the same thing, take the area of the sector and subtract the area of the triangle, aren't we going to be left with this white part? So if we subtract that away, we're going to be left with the white part, which is the shaded part here. That's going to equal the area of the segment. So finding the area of a segment is going to take a little work. You have to find the area of the sector. You have to subtract the area of the triangle. And then what you're left with is this triangle right here, this highlighted one. If you subtract that triangle away from the sector, you're left with the white part out here, which is actually this part, right? The segment part. So here's our first example. We're going to find the area of the shaded segment. We're going to round our answer to the nearest tenth. So first thing we need to do is find the area of the sector. So the area of the sector is equal to, how do I get that started? I need a fractional part, right? 90 over 360. But what part of the circle is this? We know this one. It's a quarter of the circle. 90 over 360 is also a quarter. Times pi r squared, right? What's r? 10. So pi times 10 squared. What's 10 squared? 100. What's 100 divided by 4? 25. So we're looking at 25 pi for the area of the sector. Now we got to find the area of that triangle, this white triangle right here. So we're going to go find the area of the triangle. What's the easiest way to find the area of that triangle? Half. What's the base? What's the height? So what's 10 times 10? 100. What's half 100? 50. So the area of our segment is equal to the area of our sector minus the area of that triangle. That's going to leave just the yellow. .25 pi minus 50. It's about 28.5 on my calculator. Anybody verify that? What are my units here? Square inches. Good.
I verified that.
28.5 square inches. So it's not that bad, especially when they give us a right triangle. If they didn't give us a right triangle, finding the area of the triangle, we might have to use the sine formula that does that. Because we're going to have the radiuses and the included angle in that case. So the sine formula might be necessary. You guys just learned all there is to learn today.
Darn. Is there more?
Of course.